Okay, folks, we'll continue on looking at the energy systems that we have done for the last couple of sessions. This graph shows basically how long each energy system takes to operate, it will come into operation, and then how long it will last. The first one here being the ATPPC system, lasting only approximately 30 seconds. The second one being the short-term energy system here with anaerobic glycolysis, again lasting approximately 2 minutes, reaching its peak, before then being taken over by the longer-term energy system being the aerobic system. And as you can see, the line extends upwards, giving an indication that that energy system is somewhat inexhaustible depending on the level of intensity. Now, this graph looks more at the interplay of the energy systems, all three of them being used together. As you can see at the top, it does say all activities use some energy from all three systems. The energy systems overlap. That's really important. They overlap. They never work independently. They all work at the same time, and as you can see, even the phosphate energy system, once it's reached its peak, which is very early on up here, it even continues to function throughout the activity. The anaerobic glycolysis again takes over from the ATPPC system, and then you can see here, this is a better indication of the aerobic system taking over and looking at the long-term use of the aerobic glycolysis, or long-term use of energy through aerobic glycolysis, which we've spoken about beforehand. Now, here, it just gives an example of the percentages of the different energy systems being used and the duration of the activity. It's not rocket science. 0 to 10 seconds here, 94% roughly anaerobic energy, 6% roughly aerobic energy. Getting right down to here, to 21% of anaerobic and 79% aerobic. Basically, it indicates that the longer the activity goes, okay, the less you will use percentage-wise of the anaerobic energy system and the increase for the aerobic energy system. And again, this is just another way to look at it. You've got the duration of the event, intensity, and then the primary energy system. And as you can see again, looking at the duration of the event, the longer the event goes, depending again on the intensity, the different energy system will become predominant. Now remember, it's predominant, it doesn't operate independently. It is just becoming the dominant energy system. Okay, and you can see the pictures here indicate different types of activities that would fall into those different events. The pole vault being very short, a sprinting event being a little bit longer, but again higher intensity, and then a long distance event there, obviously longer with a lower intensity, relying on the aerobic energy system. So now we get on to the checkpoint questions, and we've got briefly discussed what you understand the energy system interplay to mean. All right, now importantly, we say discuss. So this is not a chance for you to just do one sentence. You need to discuss it. You need to explain what you understand it to mean. An explanation is not one sentence. It also says that you need to choose a sport. Now, in choosing that sport, what you really should do is give consideration to a sport that has different levels of intensities at different times. That will give you a little bit more of an opportunity to say how you understand how the energy systems interplay. In question 5, even though all three systems contribute to energy production, why does the lactic acid system take longer to peak than the ATPPC system? That is talking about what we've already covered in previous lessons, looking at the different complexities of the chemical reactions for the different energy systems. The ATPPC system has less complicated chemical reactions than the lactic acid system, and that will give you some idea as to why the lactic acid system takes longer to kick in. Then the last question, how is it possible to use the lactic acid system repeatedly during continuous exercise, whereas the ATPPC system can't, without recovery? You need to look at the availability of the ATPPC, and remember that the ATPPC does not replenish itself without complete rest, whereas the lactic acid system is a little bit different, and we've already covered that when we talk about the metabolic byproducts of the lactic acid system previously. So there you go.